to summarize, transformers are an architecture, a neural network architecture, which scale well, extremely well, to our contemporary hardware and train well. So we've sort of iterated as a community over a bag of tricks that makes the training of these networks with the right optimizer pretty good across an extremely diverse range of tasks, such that you don't really need to spend a lot of time messing around with your training and evaluation setup from an optimization standpoint. You need to reason a lot about the data. Obviously, hyperparameters still matter, so you want to do grid searches, etc. But you don't really need to sort of like overthink the choice of optimizer or start building a lot of like domain specific stuff into your architecture unless it was like mission critical to get every last sort of bit of performance out of it, and even then. So this model architecture led to the foundation models that we trained with it serving as starting points for downstream models that are obtained through fine tuning, and obviously you can further sort of manipulate either the foundation models directly or the downstream models through prompt engineering. And the representations and the mechanics of these models and their derivative models transfer well to downstream tasks and abilities. But so what are these abilities, and perhaps more importantly, what about these models makes them adapt so well? I feel that's not just doesn't just pop out intuitively out of the fact that we have a transformer that we train on a lot of data, because we've had other similar architectures in the past, and we've trained LSTMs over lots of data, and you didn't necessarily see this. So let's talk about the abilities first. Let me move my little window back down here. Up. Okay, there we are. Let's talk about a few of these applications. And again, this is not at all meant to be an exhaustive or even an attempt at an exhaustive enumeration, but just some of the recent sort of topical areas that I think are quite interesting exemplars of what you can do with this class of architecture. So the first was Lambda, which was Google's version of ChatGPT, and I say this with scare quotes because this actually came out publicly much earlier than ChatGPT. Lambda was the paper was produced at the beginning of 2022, and this model then evolved to in some sense, yield a technology like Bard, which is now consumer facing from Google. But at the time, this was just an academic paper and a tech report, and the model was not accessible to people. So perhaps that's why something that effectively, to me, was actually more amazing than ChatGPT, because it could search the web and operate a calculator on day zero, and was quite a transformative moment in this kind of like conversational instruction following kind of literature, or at least conversation, like goal oriented dialogue method space. But that's perhaps why I didn't have the same sort of like resonance with the public. Nonetheless, I read this paper and I was like, this is astounding stuff, and I quit my job at Facebook to go and get back into startups at that point, which I did for about a year and a half. So yeah, so the idea here was so simple. It was effectively just take a large transformer, pre-train it on web text, try and put in more, either fine tune it on more text that has a large amount of dialogue, or mix in more dialogue in your pre-training phase, and then the astounding thing is then they got it to be a better dialogue agent through just further training, just a little bit of further training with particular structures. And they introduced this notion of like treating the large language model as a self-discriminator over particular attributes, like whether or not a candidate output sentence was interesting or toxic or informative or specific, and then having the model score its own work along these axes. And this ability was inculcated in it simply by having that information available as like sub training sets that the model would be fine tuned on. Then at generation time, you could generate some candidates, have the model score them by pretending to be a discriminative model, which is very simple to do with a generative model, and then take the candidates that you like best according to however you want to weigh the scores. So quite a powerful idea there, just to like have significant more controlled generation just through a bit of fine tuning. And then again, the similar idea, they started adding tool use to this model, so getting the model to operate on a search engine and on a calculator simply by annotating data regarding when during the conversations collected from annotators. The annotators had relied on a search engine to produce the answer. By simply putting that into a domain-specific language, like saying, okay, when you see the token search in full caps, like, don't present what comes next to the user, but pass it on to the search engine and pass the results back to the model. They trained the model to learn to search, learn to formulate the query, and learn how to interpret the results of the search. And to even do this iteratively, like several times until an appropriate result was found. And this is like highly sophisticated behavior relative to I think anything that had been seen in the previous few years. An astounding inflection point, and it still surprises me a little that this wasn't sort of like a commercial tipping point here. But again, you got to release things. um,